Very good evening everyone. Welcome back to pantechelearning channel. This is R. Divyanjali from Pantech. Dear participants, I would like to welcome everyone to the pleasant evening session. Before starting the session, my dear participants, am I audible to all of you? Yes, very good evening. Very good evening. Hello everyone. Am I audible to all of you? Okay, it's audible, right? Okay, fine. So we have come up to the second day session of our masterclass Data Science 2.0 version. Deep Learning Masterclass, right? So we are on the second day. Let us see what we are going to learn on this second day. Okay, fine. Yeah, we are on day 2. So in today's session, we'll be discussing something about neural networks and its classification. What are the main neural networks we are having? Okay, first of all, what is this neural network? Yesterday in the first day session, we have learned or we have understood something like what is deep learning, why it is useful, okay, and what is its importance. This and all we have learned in the yesterday session, right? What is deep learning? Let us recall that first of all. What is deep learning? It's a sub branch of AI or an application of machine learning, where in deep learning we are going to work with neural networks. Why only neural networks is because our human brain is made up of neurons connection. Our information is being passed with the help of connections. So only we are creating some networks. Okay, those with the help of neurons we are going to create them. That's why we are calling it as a neural network. Okay, why this neural networks is because to share the information fastly, securely, as well as it should be something like more amount of data, where we can work with more amount of data along with images as well. Okay, I hope you people are understanding. Okay, in the yesterday session we have discussed something about what is deep learning, right? Today we will discuss something about neural network. The word itself is telling something like neurons connection is going to be present in the network, right? Fine. Sense of neurons, yes, of course. How it is being responding, how the information is being passed, how it is reacting, that and all it will be coming under this neural networks. Okay, fine. Neural networks, the word itself is telling us something like a network is going to be created where something like neurons connection is going to be added, right? Fine. I'll just try to explain you that in the paint. So any neural network basic architecture. What is the basic architecture we are going to have is, first is input data, right? Input layer. Second is hidden layer or dense layer. Next is output layer. Okay, generally in any neural network, basic neural network, we will have only one hidden layer. Okay, that is dense layer. But if you have multiple hidden layers, then we work with something like neural networks. It's nothing but few neural networks are there. That how we will be working, I'll show you now. Okay, so remember that the basic block diagram of a neural network consists of 3 layers: input layer, dense layer, output layer. Okay, fine. If this any network is consisting of multiple hidden layers, then we use or we treat it as neural networks, deep learning neural networks, like that. Okay, yeah. How one can define the number of layers in neural networks? I am telling about the basic neural network. Okay, so in basic neural network we will have 3 layers only. What are they? Input layer, output layer, as well as hidden layer. Okay, this is basic. I am telling about basic, and here is the block diagram. Okay, fine. So let us move on to the first slide of the session. Neural networks. What are the main types of neural networks we are having? Deep learning neural networks. First one, MLP, multi-layer perceptron. Second one CNN, convolutional layer neural network. Next is RNN, recurrent neural network. Okay. So once again I am telling the abbreviations. If you want, you can just note it down. MLP, multi-layer perceptron. CNN, convolutional neural network. RNN, recurrent neural network. What these neural networks are, how it is differentiated from each and every other. Okay, that we'll see now. Vivek Sharma, I have answered your query just now. In a basic neural network, we will have three layers: input layer, output layer, as well as a hidden layer. Okay, fine. So we'll see each and every neural network here now. Okay, first one is multi-layer perceptron neural network. Okay, so the word itself is telling it is having multiple layers. Okay, input layer will be there as usual. Yeah, input layers will be there as usual. For suppose I'll consider three inputs: x1, x2, x3. Okay, these are the input layers I am having. Now I will have hidden layers. Three hidden layers. Okay, something like h1, h2, h3. Okay, these are the hidden layers. Now next is output layers, y1, y2. These are basic neural networks, basic classification of any neural network. Okay, fine. I have considered here three neural networks: x1, x2, x3. Three input layers, right? Three input data. For suppose if I consider this, it has to be given to each and every hidden layer: h1, h2, h3. In the same way, x2 also: h1, h2, h3. In the same way, x3 input also should reach each and every hidden layer. Now what it will do, this hidden layer? It will access the input data from each and every input data. Then it will access and then it will add or sum up the data. How? It will add up something like W1 into X1. It means weight of the data and input data. Okay. That data again it has to be shared to this hidden layers data has to be shared to the output data, that is y1 and y2. So here we will be getting our output. These are the output layers. This is about the basic neural network. Okay. x1, x2, x3 are my input values or input data. That data will be shared or transferred to hidden layers where x1, x2, x3 all the data has to be shared to each and every neural network. After sharing that, it has to sum up the data. What my values are consisting of, that data it has to be calculated or sum up or added up. After adding, it has to be shared to the y1 and y2, that is output layers. Okay. Why the input is shared with every hidden layer? That is what we have to share. Why? Because we want each and every input has to be calculated, right? That's why. Okay, fine. So let us go through the what is this MLP, multi-layer perceptron network. Okay, MLP is known as multi-layer perceptron. It is a fully connected dense layers which transform any input dimensions to the desired dimensions. It means, for suppose if you have 100 input data, okay, that all 100 data we can according to our requirement, according to our need, we can reduce or we can increase the layers. Okay, so in this what we'll be doing, input dimensions to the desired dimension. It means as per our requirement we can reduce or we can increase the layers. Okay, a multi-layer perceptron is a neural network that has multiple layers. More than 3 layers is treated as multi-layer. More than 3 hidden layers. Okay, basic means only 1 or 2 like that it will be there, right? So more than 3 layers including of input and output layers, if we have more than 3 layers in a neural network, we treat it as multi-layer perceptron. Am I clear? Once again I'll tell you, in a general neural network we will have three layers: input layer, output layer, hidden or dense layer. Okay, that is the basic one. Okay, if we have, including input and output, if we have more than three layers, we treat it as multi-layer perceptron. Perceptron is nothing but neuron. Okay, a single neuron is treated as perceptron. Okay, fine. So to create a neural network, we combine neurons together so that outputs of some neurons are inputs of another neurons. It is nothing but the output of the first layer is given as the input to the second layer, input to the second hidden layer. Okay, fine. So let us go to the next slide. Yeah, multi-layer perceptron. It's the oldest neural network created by Frank Rosenblatt in 1958. It has a single neuron and is the simplest form of neural network. It is nothing but basic neural network, okay, which is having input, output and dense layers basically. Okay, so here you can see a single perceptron, single neuron. It is having inputs of x1, x2, sorry, all x1 input data I am being given to this perceptron. It will directly give me my output. Okay, understanding everyone? What happens in hidden layer? We generally store our input data there and sum up the values, sum up the weight of the input data along with input. Okay, and store and process to further layers. Okay, in simple way. Five layers in PPT. What five layers you are having here? Input, output, hidden, that's it. What happened in the hidden layer after taking the input from input layer? That's what hidden layer stores. The word itself is telling. Here we are going to store our data securely. We want our data, huge amount of data, which is very important, right? That data, if we transfer to a neural network, it has to store securely and process my information. Okay, is it understood? Fine. So here what we have done, a single perceptron is looking like, perceptron means neuron. Okay, so a single neuron which is consisting of input and a neuron connection and an output. Okay, fine. Next, MLP network application. So this neural network, what are its application means? It is used in 1 minute. Yeah, so MLP, this is used in any application, something like audio video, not audio video, something like text analysis, like that, where we can use text analysis, there we can implement this layer. Okay, so next is convolutional neural network. The word itself is telling like we have to add or multiply. Okay, what we will multiply here? Input data with hidden layers we will multiply and process the data. In CNN, we work with images and video content. Okay, convolutional neural networks are similar to feed-forward networks, but they are usually utilized for image recognition, pattern recognition, and computer vision. Computer vision means CNN also consists of hidden layers. Any neural network consists of hidden layers, but they work differently. Is it clear, Vinay? Is it clear, Vinay? Yeah. Yes. So CNN works with images or video content as well. Okay. These are similar to feed-forward networks, but they are usually utilized for image recognition, pattern recognition, and computer vision. These networks harness principles from linear algebra, particularly matrix multiplication, to identify the patterns within the image, or something like image segmentation, right, where we separate the pixels information. So there we can implement this convolutional neural network. Here is the block diagram. So what are the different layers consisting? Input layer, output layer, along with convolutional layer, pooling, activation layer, right? So these are used where in these layers we are having feature learning as well as classification layers. Okay, flatten, fully connected layers and softmax. These are the layers. 1 minute. Okay, so convolutional neural network is used for image or audio video based data. Okay, something like here you can see the block diagram. Input image will be considered. Convolution ReLU is nothing but activation layer. Okay, CNN consists of 2 more additional layers along with hidden layers. Activation layer, pooling layer. Okay, activation layer, here we have considered ReLU. We also have few more activation layers, something like ReLU only. We have discussed that in data science agenda, right? Do you remember that? In data science masterclass we have discussed about it. If you want, just recall that. Okay, fine. So next, pooling layers, convolutional ReLU, that is nothing but activation layer. Number of layers we are increasing here. Next, I have applied pattern, fully connected layers, softmax, and get the output. Identify the image or audio video. Okay, how the layers are identified? Here you can see the basic process: input layer, activation layer, pooling layer, and these are, next comes the hidden layers, next followed by output layer. Okay, Aparna, is it clear? So this network, what it will do, it will work for time series forecasting. It means, time series forecasting means, ReLU means linear unit regression algorithm. You might be using that in machine learning as well, logistic regression. Same like that. It's an activation function. We use this linear type of function. Okay. Fine. So we are discussing about time series here. What do you mean by time series? Time series. Continuous predictions. For suppose if you consider a problem statement, okay, any problem statement you can consider. For certain time period T1 it will be in 0 state. After that it will move on to the stage 1. For again certain time period T2 it will be in 1 state. After that again it will come to the next state. Okay, with equal intervals of time it is changing its state, correct? Such type of changes to a problem statement we call it as classification type of problem. Okay, where we use classification algorithms. We also have another type. If you consider any problem statement, something like Bitcoin. Okay, so its coin price. What is Bitcoin first of all? What is Bitcoin? Bitcoin, in general you can tell. Bitcoin. Digital currency, correct? So in this Bitcoin value will be there. Its value or price will be changing from minute to minute, second to second, like that, right? So such type of continuous changing predictions also we can find. There we can use this RNN, that is recurring neural networks. Okay. So here is the block diagram. You can see input layers. Next we are transferring that to hidden layers. Right. Now what is this hidden layers doing? X1 is shared to 2 hidden layers. X2 also. Okay. 2 nodes. Next I am again transferring to each and every node. Hidden layer, every node. Then get the output. Okay. Recurring network is nothing but we are sharing the data here. Okay, again back to the node 1 for rechecking purpose, like that. Okay, so here are the advantages of RNN, recurring neural network. So first advantage is possibility of processing input data of any length. So any length of input data can be processed using this RNN network. Model size not increasing with the size of input data. So if the size of input data is increasing, the model size won't increase. It is indirectly proportional. Okay. Computation takes into account historical information. So how it is going to calculate? Using historical data it is going to calculate the mathematically. Next, weights are shared across time. So according to the time it will be changing. Okay, weights means weight of my input data, input value. Okay. Next comes the drawbacks. Computation is being slow because we are working with huge amount of data. It will take time for processing the information. Okay. Next, what is the next drawback we are having? A difficulty of accessing information from a long time. So if we wanted to work with certain data, huge amount of data, it will take some trouble. It will be some trouble, right? If we work with some large amount of data, it will make our neural network so complex. Correct. As the data is increasing, the network complexity also increases. Correct. Next drawback is cannot consider any future input to a current state. For the current state, we have to give the past information only. Okay, past output only we can give. Future data we cannot take. Okay, so that is also one of the drawback using RNN. Here comes the applications which we can use for musical and sentiment analysis. Sentiment analysis means yes, it is related to data science. Everything comes under one umbrella, that is AI. AI, robotics, all this under comes under one category. Data science, image processing, OpenCV. Okay, fine. So what are the applications of RNN? Musical analysis. Next is sentiment analysis. Sentiment means what? Positive or negative. If you take some statement, whether that particular statement is positive or negative. Emotion, sentiment means emotion, okay. In general terms, okay, fine. Good answer. Okay, sentiment means positive or negative. Whether the given statement is positive or negative, that sentiment we will be analyzing from the input data. Okay. Next. Yeah, here are the differences of neural networks. Okay. Multi-layer perceptron, recurring neural network and convolutional neural network. First, we'll consider data. Okay. What type of data will be working in MLP? Tabular data. It is nothing but CSV. It is nothing but Excel sheet data. Okay. RNN works with sequential data, time series, text, audio data. Okay. CNN works with image, audio, video, like that. Okay. Next difference is recurrent connections. There are no recurrent connections. It is something like going back to the previous layer, like that. Such type of connections are not there in MLP, multi-layer, as well as CNN also we don't have. Only in recurring neural network we are having that. Okay. Next, parameter sharing, where we can share the parameters, input parameters, hidden parameters. Only in RNN and CNN only we can share. Okay. We cannot share the parameters in MLP, perceptron. Okay. Multi-layer perceptron neural network. We cannot share there. The next difference, spatial relationship. There is no spatial relationship between the input data in MLP as well as in RNN also. We have only in CNN only. Why? Because there we will be working with different layers, hidden layers. Next, vanishing and exploding gradient. We have for all the networks, we have this. Vanishing means clearing off. Okay. Exploring gradient algorithm also we are having. That algorithm is applicable for all the neural networks. Okay. So this is about the different neural networks. Yeah. So you are going to have this 10 projects in deep learning for the next 30 days. And if you want to enroll for the internship also, you can use this coupon. You can use this coupon welcome DL, so that you will be getting the offer of 400 rupees, 402 rupees. So you can get the internship with 597. Many of the people have asked about the internship link registration. This is the internship registration link. You will be getting that. Zoom the slide. Is it clear? Vijay Kumar, is it clear? Yeah. Yeah, we have even shared the registration link for internship in the comments. Just take it out. Okay. Just fill that and enroll for 1 month internship. Use this coupon welcome DL. So you'll be getting the internship with 597 rupees. Okay. Fine. So next is about what are the different neural networks and what is the difference between that neural networks. And in day 3, that is tomorrow, we'll be learning about ANN with application. Okay. So what are the different applications we are going to have in ANN and how we can implement that we'll see in tomorrow's session. Okay. So till now, any queries? Attendance link also will be shared. Please do check the comments, you will be getting that. Okay. Okay, any queries regarding these neural networks? Tomorrow we'll be starting neural network with applications, artificial CNN as well as recurring neural network with applications. Okay. Any more queries? Yeah, today we are discussing about theory only, right? So only I could not consume much of your time. Okay. Yeah, from the next 3 days will be practical applications we will be doing. How we can implement these neural networks, different neural networks, how we can implement, what is the procedure, that we'll see in the next 3 days. Any more queries? If everything is understood, please let me know that I have understood like that. Whenever you pay the internship amount, you will be receiving for the next 60 days, you can receive the data. Any files or any PPTs, codes, anything you can receive for the next 60 days. Okay. After that again you cannot take that content. What kind of Python version we are using? Okay, please do install Anaconda Navigator software in your systems. Anaconda Navigator software, if you open that Anaconda Navigator software, you will be getting something like Jupyter Notebook. So you have to install or launch it. So we are going to work in Jupyter Notebook. If you don't have that software, please use Google Collaboratory online compiler. Okay. No, MATLAB, we are not using any MATLAB. We are working with Python ideally as well as Jupyter Notebook. Python ideally of 3.6 version, 7 version, anything you can use. 3.6 plus version, anything you can use. It is suggested to prefer 3.6, 3.7, 3.8, 10. So I hope everything is cleared. Okay, fine. So again tomorrow we'll get back at 7 p.m. in the evening. Okay. So I would like to thank all the participants for making the session interactive and being on time to the session. Thank you all. Have a very nice time.